Welcome to this tutorial on VPC endpoints. In this video, we'll explore how to access AWS services privately without needing an internet gateway. VPC endpoints are a powerful feature that enhances security and performance in your AWS infrastructure. This is part of our AWS networking series, where we break down complex networking concepts into simple, easy-to-understand lessons. Before we dive into VPC endpoints, let's understand the problem they solve. Traditionally, when your resources inside a VPC need to access AWS services like S3 or DynamoDB, the traffic must leave your VPC through either an internet gateway or a NAT gateway. This means your data gets exposed to public internet routes, which poses security risks. Additionally, using a NAT gateway incurs extra costs for data processing. The external routing also introduces higher latency, making your application slower. This is where VPC endpoints come to the rescue. VPC endpoints are private connections that enable you to access AWS services without ever leaving the AWS network. Think of them as secure tunnels between your VPC and AWS services. They offer several key benefits. First, they're secure and private, keeping your data within the AWS infrastructure. Second, they provide lower latency since traffic doesn't route through the internet. Third, they're cost-efficient because you don't need to pay for NAT gateway data processing. And finally, no internet gateway is required, simplifying your architecture and improving security posture. There are two types of VPC endpoints you need to know about. The first type is gateway endpoints. These are route table-based targets that work specifically with S3 and DynamoDB only. Gateway endpoints are simple and highly efficient for these two services. The second type is interface endpoints. These use elastic network interfaces with private IP addresses in your subnet. Interface endpoints are powered by AWS PrivateLink and support most AWS services. Each type has its own use cases and characteristics, which we'll explore in detail. Let's take a closer look at gateway endpoints. When you create a gateway endpoint, it's added as a target in your VPC route tables. This means your resources automatically route traffic to the endpoint without any additional configuration. One of the best features is that gateway endpoints are completely free to use. Unlike interface endpoints, they don't create any IP addresses or elastic network interfaces. Gateway endpoints also support endpoint policies, which allow you to control access to the AWS services. However, remember that gateway endpoints are only available for S3 and DynamoDB services. Now let's explore interface endpoints. When you create an interface endpoint, AWS provisions an elastic network interface, or ENI, with a private IP address in your selected subnet. Interface endpoints are powered by AWS PrivateLink technology, which establishes secure connections. Unlike gateway endpoints, interface endpoints are not free. They're charged per hour plus data processing fees, similar to NAT gateways. However, they offer greater flexibility. Interface endpoints support security groups, allowing you to control traffic at the network level. They work with most AWS services including EC2 API, SNS, SQS, CloudWatch, and many others. Creating a gateway endpoint is straightforward. First, navigate to the VPC console and select endpoints from the sidebar. Second, choose the AWS service you want to connect to, either S3 or DynamoDB. Third, select the VPC where you want to create the endpoint. Fourth, select the route tables that should be updated with the endpoint route. AWS automatically adds the necessary routes to these tables. Fifth, optionally configure an endpoint policy to restrict access. Endpoint policies use JSON syntax similar to IAM policies. Once created, your resources can immediately start accessing the service privately. Creating an interface endpoint involves a few more steps. First, navigate to the VPC console and select endpoints. Second, choose the AWS service you want to connect to, such as EC2 API, SNS, SQS, or any supported service. Third, select your VPC and the specific subnets where the network interfaces should be created. For high availability, choose subnets in multiple availability zones. Fourth, configure security groups to control which resources can access the endpoint. Fifth, Enable private DNS, which is highly recommended. Private DNS allows your applications to use the standard AWS service endpoints, and AWS automatically routes the traffic through the VPC endpoint. Let's recap what we've learned. VPC endpoints enable private access to AWS services, eliminating the need for internet routing. Gateway endpoints are free, route table-based, and work exclusively with S3 and DynamoDB. Interface endpoints use elastic network interfaces, support most AWS services, and are priced on an hourly basis. Both types of endpoints improve security by keeping traffic within the AWS network, reduce latency by avoiding external routing, and eliminate the dependency on internet gateways. VPC endpoints are an essential tool for building secure, efficient, and cost-effective AWS architectures. Thank you for watching this tutorial on VPC endpoints.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.